And hello, and welcome back to our awesome YouTube channel, the channel where we talk all the things Kotlin and about various frameworks, about libraries, about tools and practices. And my name is Anton. Usually, I'm your host. And today with me, I have a very awesome person, an author of a library called jOOQ. Maybe someone has to pronounce it differently, but he will correct me. Lucas, I would like to welcome you to the stage.
Hello,
Hi, Lucas.
Anton.
Hi, how do you pronounce it?
jOOQ.
jOOQ. Yes,
Yes,
I
like
should have thought
jukebox.
like this. Yeah, so it's a database library, right? To access the databases, and we have different choices in the JVM ecosystem for accessing the databases, like JPA as a standard, and a few implementations, including Hibernate. And well, everything goes through JDBC anyways, right? And they're like lightweighter libraries compared to ORMs like jOOQ, maybe Query DSL, maybe some others as well. And apparently, jOOQ is very popular with Kotlin as well. I have heard people saying that they are using Kotlin with jOOQ, and Lucas actually mentioned that it's even better with Kotlin than with Java.
Yeah,
So I was sold on this. So this is why we have this session. And
excellent.
yeah, so for folks who are online and watching us, they are watching us on YouTube and on Twitch. The stream goes into two targets, and you can ask questions in the chat. I will stay on the stream and monitor the questions, and sometimes try to gently interrupt Lucas for those if it feels relevant. Otherwise, Lucas, the floor is yours, and we are waiting for cool demo with this interesting library.
Thank you very much, Anton. And you were right. So I really think, well, I'm mostly coding Java, and I hope you will forgive me if I sometimes stumble across a couple of syntax caveats here today, because I'm not coding Kotlin every day, right? So I'm mostly using Kotlin for the Kotlin integration of jOOQ. But what I've seen so far, it's really the nice integration and interoperability of Kotlin with Java libraries has been a breeze. So this has been really well done in the Kotlin ecosystem, which I'm going to show up in parts today when we talk about jOOQ. So as we said, jOOQ is a database access library, and you see a couple of examples here. This is the simplest example where we just select a simple result. So we have in jOOQ this context object. I'm just going to quickly open this. This is Java code here in this demo. So we have something that is called a DSL context. It just wraps a JDBC connection. So we have a JDBC connection that we can create like this. So today, from a previous demo I did a couple of weeks ago, I'm using CockroachDB, but you can use anything you want. So it's really, jOOQ supports 30 database products, among which CockroachDB. And then you wrap this JDBC connection in this DSL context, which is a couple of lines. You just set the connection, you set the dialect, and maybe some settings. I have some advanced settings here, which I might show later today or not. So this is all you have to do to set up jOOQ. You have a JDBC connection, and then you can start coding. So for instance, you select one from Dual or not. So Dual is in Oracle or some other databases, but you just write select one. As a simplest example, I run this. I'm using a unit test to get the IntelliJ buttons here, and I'm running this, and I'm getting a debug log output where I see the query. So you see the query with bind variables select one, the simplest possible query. The first 5 results in the result set and in the debug log output, and I print this again. So you see a nice print line, a nice 2-string rendition of your result set. I guess this is the simplest possible way to enter the ecosystem. But you're not gonna write simple queries like this. You're gonna write something like that here. In the example, I have an actor table, which is from the Sakila database. So the Sakila database, if I can just quickly show this here, you tell me if you can see this on your screen. Is that okay?
It's pretty small, but
Is it
I
small?
can if I zoom
Possible?
in. Yeah, on
Yeah,
my
let's
big
do it like
screen I
that.
can see it.
Okay. So the Sakila database is an original example database from MySQL, and those folks created some sample data, and it's a nice DVD rental store for the older folks in the audience. So if someone here still knows what a DVD is, or a VHS, where you can rent movies, so you have actors and films and relationship tables between the two, and inventory, staff, payment, etc. So this is a nice demo database that I tend to use in these kind of things. And the actor table from the schema is actually generated. So jOOQ has a code generator that generates all the tables here in this file. So this is a Kotlin file. I'm using the Kotlin generator here. So this is a Kotlin file that just lists all the tables in our schema, like address, category, city, country, etc., etc., etc. And within those tables, if you click in the table, you will see that each table has columns. So you see the actor ID here, which has a data type, long, string, string. So each table has columns with data types associated with it. And you can use this type information afterwards to run your queries. So when you run a query like that, you have actor first name and actor last name. So you can use auto-completion in your ID to type last name here. And then you see all the columns that are available on your table, right? So last name or last update or whatever. And you can't have any typos. So if you have typos in your code, then your query won't compile anymore. So all of this is the same thing for Kotlin or Java or even Scala. So it always works the same way with jOOQ. So jOOQ is an internal domain-specific language that models the SQL language directly in Java, so you can have this kind of type safety. For instance, you can write a last name like A. So you want to have all the actors that start with the letter A, and you order this by the first name. When we run this query, we see the result set immediately in the output down here. So I'm hoping Kotlin will compile this fast enough in the demo today. This is something that I've been, I said Kotlin works better than Java, but sometimes the compilation speeds are a little bit less than what I'm used to. But here we see the query. So again, you see the entire query here in the debug log output because I've configured it this way. And you see it uses automatically bind variables. So this like A here is automatically a bind variable. You don't have to worry about bind index or whatever. So you place it like there, like in a PL SQL piece of code. So if anyone here in the audience knows stored procedures, in most RDBMS or in Oracle or SQL Server or whatever, if you have a constant like that, then the compiler of the database will inline that as a bind variable, and you have the same effect with jOOQ. So you don't have to worry about parameter names or positions or whatever. So jOOQ takes care of that. It just remembers, okay, at this position, the actual value is this A and the percentage sign. So this is the query that's being executed, and now you see the result set. I've changed it to last update, so first name, last update. So you see the first 5 results of a total of 7 rows that were fetched like that. So that's pretty easy. And I've told you about type safety. We'll get more into that later on. But here first, an example where you can already use Kotlin magic. So because there are 2 things here. So first off, this destructuring here works automatically. We can have first name, last name. We can't have a third column like A. This won't compile anymore, I hope. So you see here, because this query here projects only 2 columns, you actually have to set that into 2 variables if you use this syntax here. The third one isn't specified. We can still add the third column if you want. Last update. So now it compiles again, and we put that in the local variable A. And the way this works is that the select here, when you write select with 2 columns or 3 columns, behind the scenes, what jOOQ does is it remembers the data types. So let's see if this works fast enough. So you see here, you see a record 2 of 2 types. And I'm not sure if I'm doing this correctly today with IntelliJ Kotlin, but I think in Java, the type inference is displayed here in this pop-up. So you see that these 2 types are now string, string. You can do the same thing in Kotlin, of course. You can specify the types explicitly, and then you see type inference works. This is a string, right? So we've seen before in the generated code, the string type was attached to first name, so you will get the string value here as well in your Kotlin code. You don't have to declare it, of course. You can use type inference and then the usual stuff, string interpolation, and work with the result directly. And what's nice here in this example is the whole query isn't iterable in Java, so Kotlin knows what to do with the iterable. You can use this for each loop syntax to directly iterate the result. So the only thing this could mean if you put an iterable in a for each loop is that you have to execute the query and fetch the results, which is really nice. But you could also use the for each internal iteration syntax, so it would be the same thing, right? So this is one of the Kotlin extension functions to the Java collection API, I think.
It is.
Yeah. So maybe you have larger result sets. You can still use fetch lazy. So the example I've shown before, this here fetches everything into memory and then iterates it. So this is the standard use case that you use most of the time, because usually you don't have huge result sets, but you can still go the JDBC way and use fetch lazy. And this behind the scenes has an open JDBC result set. It's completely hidden from your code, but if you use this use extension method here, then you have the same thing as in Java, the try with resources construct, where you can now lazily iterate the result set without consuming everything in one go. It's the same thing in the end, or functional-ish. So you can use the stream API. This is the Java stream API. I think in Kotlin you have similar primitives. It doesn't really matter. So you can always use the different primitives from your language and iterate over the result set in a type-safe way, no matter what your preferred style is. But type safety is really at the core of jOOQ. So I'm going to show a little bit more interesting example here where we have a union. So this union here now takes all the actors with their first and last names, and then all the customers with their first and last names. So we kind of search for all the people in our database from these two tables, and we see there's also type safety here. So if I forget one of the columns, then the Kotlin compiler will complain about this, so this doesn't compile. So we have to decipher the error message. Let's see if it's fast enough. So normally, I'm surprised now here in the Java compiler we would see an error message here, but I guess this is an extension function. Union, is
Yep.
that? I'm surprised by this. I've never tried this. So this is now no longer a jOOQ method, but a Kotlin.
It's a standard library function.
Okay. So, but if you had union all, this would be only available from jOOQ, right? So you probably use union all more often than union anyway. Now you see the compilation error. So you see the first subquery had only one column of type string. The second subquery, no, that was the first one, and the second one only has one column. So the first one has these two columns here. The second one only has one column, and that doesn't compile. It's not correct in SQL, so it shouldn't be correct in the jOOQ API either. So you can have the same effect also if you have the wrong data type. So if here I add last update, you have the same effect, because now you see it's a string in the first subquery, but now in the second one you get string local date time, and you shouldn't even be able to run this because it's completely wrong, right? So it's the same kind of feeling like when you work with the Kotlin collection API, when you have you concatenate two lists or whatever, and you don't have matching data types. It just doesn't make any sense. So the compiler will help you there, but it can also help you with SQL, of course, if you're using jOOQ. This works for predicates as well. So here we have the in predicate. In is one of the few methods in the jOOQ API that you have to escape in Kotlin, because it's a keyword in Kotlin. But the effect here is the same. So if you want to search for all the actors who are in the film actor table, right? So these are all the actors that also have films. You can write the subquery here, and you can't just go and say, okay, I want to have actor last update. Can't compare this because even within the select query here, the type that is produced is now the type of this is local date time, and you can't compare that with the column here. So you get a compilation error, which is quite clear in the end what it is. So you can easily fix this. You have to imagine this is not just when you write the query. It also happens if someone refactors your schema, maybe increments the schema with Flyway or Liquibase, and then your code will stop compiling, because after you regenerate the jOOQ code, it just doesn't compile anymore.
Could we touch actually a little bit on the code generator part? Like, how do you do that? We have some questions in the chat about it.
Perfect. So, what is there a fastest way to make this full screen? I'm not too much of an IntelliJ user, so okay, I found it.
Yeah, like this.
So I'm using Maven today, but you can also use Gradle, of course. What I'm doing here is I have this jOOQ CodeGen Maven plugin, where I just use the jOOQ edition and version, and then I plug the JDBC driver. So this connects to my CockroachDB database, but you can use any database you want. And then you specify a couple of things, and then you run this, and it just that's it, right? So I think this is the Java configuration. No, this is the generic configuration. Now I have a Java demo and a Kotlin demo. So here I'm specifying in what package I'm generating classes and in what file structure, and that's it. So you run this in your build, and it regenerates whenever you run the build.
So basically, it reads the schema and generates by what
Yes.
it sees in the schema. What
Exactly.
about the cases when you definitely know that there is an index, but it has been disabled or removed by the DBA because they think it will affect the performance of the database? I have seen cases like this. Like on the code level, there should be a constraint, but it's not physically in the database. In that case, it's basically you generate and you have to adjust it by hand, right?
Oh yeah. So you mean while you develop, you have the index, but in production you don't.
Yeah.
Like that.
Yeah.
So with an index, it's not really that important, because indexes are metadata which is used for performance only, so it doesn't affect correctness of your query. But I guess DBAs won't change your columns. But if you have an index in your generated code, that doesn't really affect anything in the jOOQ query.
Mhm. But do you always have to connect to the database? Is it possible to give it a DDL somehow?
Yeah,
And
that's the default. So by default, you connect to a database, because that will allow you to use all the vendor-specific features like store procedures and whatever, which are also generated by the code generator. But maybe you have a DDL file and you prefer working with that, and if it's not very vendor-specific, then you can parse it and generate code from that. It's going to be faster, of course, but less vendor-specific. So it's a trade-off. I generally recommend using test containers for these kind of things. So you can spin up a test containers database, which should run quite quickly, and then install your schema inside of that, and then reverse engineer that instead of the live database. But there are different approaches. So jOOQ doesn't really have any opinion on that. So there are different ways of overriding this behavior. You can implement your own database implementation for this Kotlin generator here, and then even reverse engineer your own JSON or XML files if you have this kind of representation of your metadata. It doesn't really matter to jOOQ. You can also reverse engineer JPA annotated entities. So if you do that, jOOQ will try to it will use Spring behind the scenes and Hibernate to reverse engineer the entities, and then generate an in-memory H2 database and reverse engineer that for the jOOQ code. So it's an entire pipeline that you can use. It doesn't really matter to jOOQ how you specify
you
your schema.
mentioned test containers. Is there any specific like integration with test containers, or is just a tool like that you can use next to jOOQ and then do whatever you want?
Yeah, you should use it next to jOOQ. So people have asked for an integration, but every time I looked at it, I thought, okay, there are so many flags to configure in test containers, and then you would have to be able to configure it from jOOQ via jOOQ to test containers. Why not just run a Maven plugin just before this plugin, where you spin up the test containers database, and then this plugin here will have it available anyway. So
Yeah.
I mean, these things are sufficiently self-preserved, self-contained, that I don't think you should integrate them more deeply.
Okay.
I mean, the one way to do it is with the test containers JDBC URL. You just provide that here, and if then jOOQ will find the driver, the test containers driver on the class path, it will automatically use test containers for that. Or another one is to spin up a test container and put the URL that is generated from test containers in the properties of Maven, of the Maven process, and then you can use that. There are different approaches to this. Yeah.
All right.
So code generation isn't really that much rocket science. It just generates these files from whatever schema representation you have, and then you can start coding with it. So I want to show some other things. You interrupt me if someone in the audience has some specific interests. But otherwise, I'll just continue. So type safety is everywhere. So here you see aliasing. Aliasing, like in SQL, you rename the actor table and call it A. And now there's some sort of local variable called A here where you can see it's still of type actor. So this is still the same type as this one. So you can still dereference columns from it. So when you type A here, A dot something, you see actor ID. You can still autocomplete everything on the alias as well. So this is very nice. It feels kind of like SQL. This is an important part of the jOOQ API, that even if it's an internal DSL, Every aspect of the DSL feels like SQL. So for instance, when you type join here, you can't just go and put the on clause here. It doesn't compile, right? This is not correct SQL, so it's always join on. Or you cannot have where and then join something. That doesn't make sense either, right? So I've seen other DSLs who are just how do you put it, builder APIs where you can put random orders of operations, but in jOOQ it's really important that if you have a SQL syntax, and the jOOQ API will try to mimic the syntax as much as possible to help you get the right semantics. So this is a Kotlin specific feature here where you can go a step further than aliasing. I don't know if it's very popular or even recommended. I just discovered it and thought this is kind of neat. So you can use with to put actor as the this reference. So from now on you can omit the qualification of the columns. So just write first name, last name. It's just a trick, I guess. For Kotlin developers, it's just something ordinary. I found it kind of neat.
It reminds of Pascal a little bit, but
Pascal?
Yeah.
I don't remember. Did Pascal also have this? JavaScript
Yeah.
has it, but I think it's not recommended to use.
Well, in Kotlin, it's pretty common to use if you actually want to avoid referencing the same instance somewhere in this block of code. And
but that's what we're doing here, right? So first name, last name, first name. So all these
Yeah.
queries here, you see all the time, we're referencing these columns. It can be useful if you don't have any joins, that is.
It's just a little bit weird that we have with actor and then from actor. Although it's correct, it's still correct, it still would work.
You would prefer this?
Yeah, but then it's also strange. So
it's strange, isn't it?
Yeah.
I mean, now it works like SQL, right? In SQL, you still have to write actor, but now this from actor in SQL kind of works like with. So from now on, you can use actor columns in select and where. I don't specifically recommend it. It's just I thought it was kind of fun to see that all of these language features work out of the box.
Yeah.
Now this is one of the features that I really like most in jOOQ. It's been added, I think, in 3.11. Something that I think should go into the SQL standard as well. I'm not sure if Hibernate invented it, but Hibernate has had it for a long time. It's called Implicit Join in Hibernate, and I took over this name, where you have a foreign key relationship. So the customer has an address, and the address has a city, and the city has a country, right? So we have this metadata in the DDL files, so we can use it in the code generator to generate these synthetic path constructs here. So what happens when we type this? So we have customer address. We can autocomplete stuff here on the address field, and we see address has maybe postal code and all these kind of columns. So this is an ordinary address table reference, but it's a alias behind the scenes. So what happens if I run this query? If I run this query, I will get a join tree from jOOQ, which generates the necessary left joins or inner joins depending on the foreign key specification to do that for me. And we'll see the SQL query here. It uses nested syntax of these inner joins. So it's inner join because the foreign key is mandatory. We see this nested syntax. So this allows us to have arbitrary tree structures, right? So we can have arbitrary branching of these join trees with implicit joins, and it will always work. So it's much easier to write it this way, in my opinion, than to actually spell out all the joins explicitly. There's no functional difference in the end. The query is exactly the same. It will run at the same speed in your database. But I think personally, I find this much easier to write from time to time. So this is a really nice feature. And it's type safe. As I've seen, we can autocomplete everything at every step here, city ID or whatever you want to project. Well, I really like how this works out in Kotlin, even more than in Java, because in Kotlin now these are properties instead of just methods, right? Or functions. So you can use the property syntax, and it kind of feels like a column. And you can actually project the table itself. So here, I'm no longer projecting columns. So sometimes you just want to have the entire customer record and the entire country record. So I just didn't use a customer first name and last name, right? So I didn't write it like this. I just projected the entire customer. This is a new feature. I'm not sure of 3.16 or 17, and now I'm getting nested records back. So if you're using ORMs, many ORMs also have these nested records. In jOOQ, A nested record is always a record and not an entity. So what we see here is just a nested record. In a CockroachDB, we can emulate that with the row operator. In Postgres, you would see the customer table. Depending on the dialect, you see a different SQL output to emulate this behavior. And you see again the implicit join. So the entire query here, this was the entire query in jOOQ, and it's much simpler in my opinion than writing that out in a SQL directly. But it's still very SQL compatible, right? So what we see here now is the customer record. And you see the customer record is also a generated type. So jOOQ also generates record types for each table, which you can use to access first name and last name properties in a type-safe way, right? So this is a getter in the Java code if you generate it with Java, or a property in Kotlin on the record.
All right.
All right.
This looks really like magic to me when I read the code. Like it's a select. I say what to select, and then there is just from, order by, limit, fetch, single. I don't really see any joins there, right? That's why they are implicit.
Yeah.
That is by design, but this is something totally unexpected.
You can spell out the joins. I mean, you can write join address if you
Yeah.
prefer the syntax. It's a matter of taste, right? So you can write this customer address ID. It's a little bit verbose. People always criticize SQL for being verbose, but some people prefer that,
But
right?
it
So
means
you can do
that
it like this, and then
basically the API that you have there reacts to the input to the select function, right?
yeah.
Okay.
But behind the scenes, there's a traversal. When we render the SQL statement in jOOQ, we traverse the entire object tree that you generate here. So you're actually writing an object tree. You don't see it because it looks like actual SQL, but in the end, it's an expression tree. And we check if there are any of these path expressions. That means we have to append at the right specification here, because you start with customer. You have to append this to this customer table. And while rendering the SQL, we just remember what has to be patched here in this case.
Okay.
It's a tricky algorithm, of course, but it's not really rocket science, because it's always obvious what is meant. So it's always a 2-1 relationship. But these things get even more mighty, in my opinion, if you add ad hoc converters. So ad hoc converters means you don't want to work with the jOOQ generated record types. You want to work with your own data classes. You want to wrap your country name in a string in a country data class, and your customer in a first name, last name, and a country. So you can nest these things, and everything that you see here is still type safe, right? So we nest the country string in a country data class with this constructor reference, and then we nest the whole structure here, these 3 columns, in a customer data class. And I think this could even be simplified with a extension function. You don't have to write these double parentheses. And now you get customer types back from this whole query, and it's always type safe. So if you switch the order of these columns, you will see that it no longer compiles anymore, because the order of parameters is no longer correct, right? So we have string, country, string, but you are expecting string, string, country. So everything is always type safe in jOOQ, no matter what feature you're using. I didn't know this. I like how IntelliJ actually understands it has to move the comma
comma.
here. Yeah, I learned something about IntelliJ today. Excellent.
Actually, in Kotlin, we have a trailing comma. So you could have the comma
everywhere?
after the
You
last
can put
line.
it here?
It should.
Wow. Okay, that was a controversial feature, I guess. No?
Yeah, well, actually, when working with this kind of code or data or whatever text, it actually makes sense.
Yeah, especially when writing a code generator, it's much easier then. Yeah. Although you never know when it works and when it doesn't. So I'm going to take it a little bit further. This is a feature that I really love, the multiset operators. So this is really, I think, what all ORMs should have. So far we've only joined 2-1 relationships, but often you join too many relationships as well. So for instance, a film, if you go to the film table, we have the film table here. And we'll remember a film has many actors. So we can kind of create a nested loop here where we join by the film ID. So what we see here is we take for each film the film actor relationship, and then take from that film actor the first and last name of the actor, right? So every film has multiple actors, and we take the actor's first and last name. And here again, every film has multiple categories, and we take the category name as well. And we do that for the first 5 films. So let's see what happens here. All of this is again type safe, but this operator here, which is a part of the SQL standard, is hardly ever implemented. So Informix and Oracle have it. This is a SQL standard nest collection operator, but almost all other database products don't have it. So what does jOOQ do? jOOQ generates behind the scene for CockroachDB a JSON query. So we actually have a subquery here where we find for each film the film actor relationship. We again have the implicit joins here. And then we get the first and last name for each actor per film. And we aggregate all of this in a JSON array, right? So JSON is only used as a serialization mechanism behind the scenes because this database product, CockroachDB, doesn't support multiset. So we can't actually, really nest a collection in the native SQL syntax, but we can easily emulate it. And we do the same thing for categories. And the result set that we'll see in the end is going to be here. So this is the toString output of the result set. Title is an ordinary column. And here we have a nested collection. So the nested collection is printed as a list of these records, right? So first and last name, and the same thing with the categories. So this is what we get when we toString this. When we format it as JSON, this is what was serialized. So jOOQ serializes stuff as arrays of arrays. So it's a little bit more condensed than if it were arrays of records. So it works better this way. But you can also print the result set as XML if you want. So this is what I'm doing here. I'm printing this stuff as JSON or XML just to show you what's happening. So if you can imagine what happens behind the scenes, you have a record for each film with a title. We have this multiset, which is a nested result set with new records. And all of this is, again, type safe. So if you want to look at what the type of this variable here is, you're not going to write it down normally. So usually type inferences, you're going to be your friend with the jOOQ API, as with any structurally typed API like this. And you see, we're getting a result of a record with degree 3. So what do we have here? If you format this, we can maybe read it a little bit better. So we have one film title column, right? So this is the string column here. Then we have a nested result set with a record of 2 columns, and each column has type string, and then another nested result set of 1 column of type string again. And whenever we change this stuff here, so we change this from last name to last update again, we'll see it won't compile. Why? Because here we would have to update the type as well, right? So everything is always type safe with jOOQ, even if you do this kind of crazy nesting, right? And you're not going to work with these types. These types are just auxiliary types in jOOQ. Usually you have your data classes. I've shown you this before. So if you combine this multiset operator with these data class structures, so we have, again, a name where we wrap the first and last name, maybe something that we always want to do. Then we put the actor in the name object. So we can even nest records into multisets. And then here categories is something simple. And the final result we want to have is just a film. Data class with a title column of type string, a nested list of actors, and a nested list of categories. And all of this is done here, right? So we do this mapping. So mapping is a extension function here, and this one is from the Java API, where it just map this nested row. We have a nested row. We map that into the name. And we can't, again, it's always type safe on every level. So if you have last update, doesn't compile at this level, right? So it's just wrong. We wanted 2 strings, so we have to put 2 strings in here. We have to have a name and what was the other thing? Just the name to have an actor list, right? So actor requires a name, and we have a list of actors, which we put in the end in this list here of the film table. And whatever you change, no matter what you change here, you can change whatever you want. It doesn't compile anymore. At some point, the Kotlin compiler will just notice, okay, you did something wrong. The whole hierarchy of data types that you typed here must correspond to whatever you mapped. So whatever you break, if you update your schema or you rewrite your query, you will always have type safety on all of these levels. So I think this is why I say multiset combined with ad hoc converters. This is really what every ORM should do in the end, because most of the time when you map stuff, you have something like a table and you want to have that in some sort of data class and you want to nest stuff, right? So in rare cases, you want to have the graph representation of your data because you modify it and you store it back, and you might use JPA for that. But in most of the cases, you just project stuff, and you want to project stuff in some JSON structure or whatever. So you can even project the JSON itself. You don't have to use multiset. If you're sending the data directly to a JavaScript client, you can use JSON ArrayAg or whatever from your database directly natively. So all of this stuff is available. So whatever you can do in SQL, you can do in jOOQ. But I also always like to show these multiset things because it's really, really powerful. And you don't have to map stuff as data classes. You can also map stuff as maps. So here is an example where I mapped the multiset into a map. And again, because I have two columns here, so I have a local date column and I have an amount column. I cast it as local date because it's a local date time actually, but I wanted to cast it as local date to find for each film, how much money did we make on each date, right? So for each film, how much money did we make on each date? So I'm collecting this into a map here, and I get this map. It's completely type safe again. I can't change these things. If I remove this, now this into map shouldn't compile anymore because it expects two columns to be placed into this map. Right, so I have again a type safe way of collecting this stuff. So let's run this query to just quickly see what I'm getting out of this. So I'm getting a film with their revenue, and this is the output. So film, each film with this map. So you have the date and the amount that we made on each day, right? So the data structure here in the two-string representation is just a map. So in the end, the point of jOOQ is what you have is you think in terms of SQL. You have your SQL statement. It might even be fancy like with multiset, but it doesn't have to be. You can use any SQL syntax you want, also any function you want to use. And you want to write that down in Kotlin because you want to have this embedded in your Kotlin code and you want to have it part of it. And you don't want to use the external domain-specific language that SQL normally is without the type safety. So while IntelliJ helps you autocomplete your SQL statements, it doesn't validate them. So at build time, you can still have invalid SQL that you only check at runtime. And even if you didn't have these problems because you have many integration tests, with these SQL strings here, when you're using the API, you can run it on any database. So if the database product that you're using behind the scenes isn't CockroachDB, the same API will still work with Oracle, for example. So just a quick example. I have here a little bit of code. If I activate this, so what does it do? It's a little bit of more advanced. I have an execute listener. So this execute listener listens to every query that is being run with jOOQ. And when it executes, it just quickly runs. So this is Java code, I think. Don't be scared. But it just quickly runs a re-rendering algorithm where it renders the same query in a different dialect. So just to illustrate today what I'm showing to you. So I'm just going to print out the same query in these four dialects, right? Show you that every query can be translated to all sorts of dialects. So I'm just going to use a simpler query so the two-string isn't too big. So what would be a simple query like this one here? And you will see immediately the query will be printed now in the four dialects. I hope so. In MySQL, you see this is what would be coming out in MySQL. We have these backticks here. In Oracle, the same query would be using the double quotes. So this is not very interesting. It's just the identifiers. So the different style of query will appear in your print line. But if you use the limit clause, for instance, I have an example with limit and offset. You see what happens when we use limit and offset. This is very hard to standardize across database products. So we see now in MySQL, you would get limit and offset, which is probably the simplest way of expressing this. Oracle supports the SQL standard offset fetch. So Oracle 12 has started supporting this syntax finally, so you can use offset fetch here. Also in Postgres and in SQL Server also. Okay, this isn't, again, very interesting now, but by now everyone implemented the standard, but in the old days, SQL Server would use top, and jOOQ also supports this still if you're using an old SQL Server version. But the point I'm trying to make here is really all of these database products work really, really differently. So you can use the same query and it should actually run on all of these database products. So I don't think you can use that in Kotlin. So in Java, if you're using Java, there's a type checker where you can actually type check all of these support annotations. So if you want to check out the jOOQ API, for instance, offset here, offset isn't supported everywhere. You see the support annotation tells you which dialects support offset. And you can statically type check these annotations if you want to be sure that a query will run on your dialect without running it in production or in your test system. But I'm not sure if this kind of annotation processing is available in Kotlin. I've never checked.
It is, but
It
it
is?
has some interesting corner cases, let's say, like that. It's a story that never ends, and
Okay.
we're trying to improve it. There is a new tool for working with this kind of things in Kotlin by Google. They
Okay.
started
Yeah, error prone.
KSP. It's KSP, and
KSP, okay.
it's basically the utility for annotation processing and for metaprogramming in Kotlin. And I hope that this will be integrated into the ecosystem a little more.
Yeah.
We actually have quite a few questions in
Yeah,
chat.
go
I
ahead.
think it's a good time to ask. Is there support for window functions?
Yes, of course. So let's look at
Sure.
this DSL class. So I didn't show it before. The DSL class is just an import I placed here, right? So this DSL asterisk import imports everything from the DSL class, and among the things that are available there are window functions like row number or rank or dense rank or whatever. So all of this is available as well.
Okay. Cool. There are quite a few questions that actually fall into the same bin about async. So, is it blocking or async? Does it work with coroutines? Is it async and so on? Like,
Yeah.
can jOOQ work asynchronously and so on? So,
So
I
the
think it's
async
all the same.
API in jOOQ, I'm just going to go here. So there's an async API that returns a completable future, right? So now your result is a completable future, a completion stage from the Java ecosystem. That's probably not what you want. So this is blocking. It just blocks in a different thread. You can provide an executor. But what's really nice, since recently, jOOQ will support R2DBC. So I don't know if anyone knows R2DBC in the audience, but the jOOQ result query extends the reactive streams publisher. So you can place a query in a flux. I don't have an example yet in this demo, but you can place a query in a flux and you get the R type back from the flux. So you can execute the query reactively if you have an R2DBC driver. So R2DBC is an alternative to JDBC. It's completely non-blocking and reactive. And there are bridges to Kotlin coroutines. So I think that works quite nicely. I have yet to try it myself. But if you integrate the bridge between the reactive streams API and the Kotlin coroutines, you should be able to directly integrate jOOQ queries in a suspending way.
Right.
But I haven't tried it, and I'm not feeling familiar enough to make a demo right now.
Okay. I think there is one question by a person who actually uses jOOQ. So, what's the status on having non-null columns in our DDL show up on as
Yeah.
non-nullable properties in the generated jOOQ record code?
Yeah, see, a lot of people in Kotlin think that the holy grail is their sacred non-nullability. Now, I'm telling you something. Let me ask you one thing. If we have a query like this, so maybe for customers we don't care about the first name, right? For customers we don't care about first name, so this is nullable. But for actors we always care about it, so this would be non-nullable. And now we create a union. So what is the data type of this union? The first column. What is it? Right? There's not really a good answer to all of these questions. So all of the people who think that they want to have first name, okay, for instance, here the actor ID, it's probably a primary key, so we should get this, right? So the Kotlin user would like to have a long type here without the question mark.
Most
But it's a
likely.
lie. Even if for the primary key, it's a lie. If you left join a primary key, it's nullable again, right? So as soon as you left join
Right.
something in SQL, it's nullable. And there are really hairy, weird syntaxes with group by and grouping sets that can turn non-nullable things into nullable things and vice versa. So it's a lie. So even if the jOOQ code generator would generate this, it would be really easy for the code generator to generate this. It would be a lie. And I'm promising you that everyone who thinks they want that will end up not wanting it. So if this is something that bothers you, then maybe you should use the Java generator instead of the Kotlin generator, because the Java generator will just generate the Java code without this nullability information, and you will get the behavior of T type, right? With this non-denotable Kotlin type, you can't write this type in
We call
Kotlin.
them platform types actually,
Platform
and
types,
they are actually nullable. And but the compiler will say, okay, it's a
yeah,
platform type. I will not be checking it. It's your responsibility.
exactly.
It's also not a great idea. I think how people should think about this whole situation is that you're building a boundary with an external world of
Hmm.
data. So you bring in the data somewhere, and it will be null no matter what no matter what you try to do in your code.
Hmm.
So you actually, like, to get this null safety in Kotlin, you have to design your program with a boundary. Like,
Yes,
if you're crossing the boundary from data to Kotlin or from Java to Kotlin, there might be nulls, and you have to check for them. And as soon as you have built the boundary with non-nullable types, when you get into the Kotlin code, then you're safe, kind of.
exactly. That's how I think about it as well. Now, it would be really nice, all the people who argue in favor of adding more nullability support they think of queries like this, where it really looks trivial, and here we could guarantee it, and it will sound. But they will write eventually those non-sound queries where it's not sound anymore, and then they will run into the problems they have in Java, right? So I think if this is important to you, then I think maybe try using the Java generator. The Java generator generates Java code. It's completely interoperable as well. It won't change much to your Kotlin queries. You can still create Kotlin queries. You can still destructure stuff, and then instead of first name string type here, instead of this type, you will get this type, which you can't write down, and you can have this convenience that you want, right? You can say, okay, I don't care, I know what I'm doing, I don't care here. But if you're using the Kotlin code generator with jOOQ, then you will always get the question mark types, right? So that's how it is. I don't have a solution here yet. It's really, I know people are pressing me on the relevant GitHub issue. It's the highest upvoted issue on the jOOQ tracker to finally address this. And yeah, what I will do in the end is I will have a flag where people who think they know what they're doing can opt into this, and then they can shoot themselves in the foot. But it's then their responsibility. I've seen a couple of other DSLs, especially in Scala, who have tried to solve this differently by completely rewriting the DSL and completely rethinking the language. But that's not how jOOQ works. So jOOQ really wants you to be able to express exactly what you want here. So you have everything you need, like connect by no cycle. You have all the SQL features, right? You have window, which some of you have never used before. You have qualify. You can use all the SQL features. You can have writing SQL features. So you can have DML statements like insert update. You have all the clauses of insert update. And jOOQ really wants you to think in terms of your vendor specific feature that you want to use also in jOOQ. So this is always a compromise. So this means this nullability problem is not the top priority for jOOQ. It won't be. So what top priority is always to support all of SQL as much as possible.
Makes sense. Okay, are we running to the end of the session, or is there anything you want to show more? Because I
How much
have a
time
few
do I
questions.
have? I can answer
Uh,
questions or
about 10 minutes, but there
one
was a
minute.
question about the stored procedures.
Yeah, I unfortunately don't have an example in this demo, but store procedures are supported as well. So you can use, if you're using Oracle, all of it is supported, including Oracle PL/SQL data types, or if you're using Postgres as well. So the demo project with CockroachDB doesn't support store procedures because CockroachDB doesn't support them, but jOOQ does. So the code generator will generate stubs for you to call, so everything is type safe again. So if you have a store procedures with two parameters and the result type, you get two parameters in this Java in the Kotlin function and the result type, and you can call that without thinking about how to bind variables, etc.
All right. Okay, then I will have two very general questions to you.
Yeah.
The first one is actually coming from Mark about
Oh, Mark, hi.
a feature in SQL. What would you add? What would it be?
The SQL standard. Well, I would definitely add the implicit join feature because it's where is it again? It's very obvious what it means, and I think all of the SQL databases could immediately implement it, right? So when you have a child table with a foreign key to a parent table, the only question is how to call this relation here. So jOOQ generates the name of the table, but you can also use the foreign key name in the code generator. But it's very obvious what it means. Once you resolve the naming problem, then it's very obvious what it means. And this path structure here, this is really something that everyone wants, and it's independent of being an ORM or whatever. It's just very obvious. And I think actually Microsoft Access has something like that. So if I remember correctly, Microsoft Access, you can actually traverse your relationships like that. It's really, maybe not with this syntax, but it's really nice to think about parent relationships like that. It's actually also part of the relational algebra. So relational algebra kind of thinks of foreign keys like something you import into your child table. So you can import the parent table into the child table, and it makes perfect sense. So for Mark's question, that is the one thing that I would most urgently want to standardize.
I see. Well, and the last one comes from me. What is your favorite Kotlin feature?
Oh, the favorite Kotlin feature. I think from a perspective of a Java developer, it's this destructuring. I would really love to have that in Java as well, especially
And for,
because it's so nice with jOOQ, because jOOQ has all these type safety things. So I actually, if you look at the type that is behind this, so the type is record 2 or 3 or 4 or 5. And just because of you, Kotlin fans, I've added all of these methods here just for you folks, so you can actually use this feature. This wasn't there before. I realized it was so simple for jOOQ to integrate with Kotlin destructuring. So yeah, that's probably my favorite one.
I see. And for the generator, when you are kind of creating the generated SQL, um, like you said from the perspective of Java developer, but from the perspective, are there any other perspectives?
Yeah, I can't say. I have never written productive Kotlin code, so I'm not
I
sure.
see. Okay.
I guess there are more features, like from the jOOQ perspective again. Where's this mapping? I mean, I would love to be able to write this in Java as well. This is really something. I don't think we'll ever get this, but this kind of extension function syntax, that is now, this is part of the jOOQ Kotlin extension module. You can just pull
Mm-hmm.
this in. So you have the jOOQ Kotlin extension model here, which has all of these extensions, and it just binds things that are otherwise very difficult to bind on a type. So now you can bind it on a type instead of putting it on a type directly, and that makes for a very much more efficient DSL. So I think these
Exactly.
features are really excellent for libraries like jOOQ.
Yeah, this is where I was leading to. I kind of gently pushed you towards extension functions, and I was pretty sure that you have extra extensions for Kotlin,
Yeah,
because this is what a lot of Java libraries and frameworks started doing for Kotlin developers. They add an extra module with nice extensions like that are useful with this framework or this library, so that it's more convenient for Kotlin developers to use this library in a idiomatic or
yeah.
DSL way.
Yeah, I'm actually still thinking about this. So if any of you existing users, have more ideas of what should be standardized here in the jOOQ Kotlin extension, go for it.
Cool. All right, then let's wrap it up here. And it was a very interesting session, Lucas. Thank you very much. And
Thank you for having
thanks
me.
all the folks who came to the stream asking questions. And if you have more questions, just come asking in the comments below. This session is recorded, obviously. And yeah, have a nice one, and let's meet again. We will have more session coming soon on this channel, so subscribe and don't miss the notification, like set the bell for the notifications. So goodbye.
Bye.